So here we are with our finished trench material or trench mud material. This is going to be the final result of our 5-stage tutorial series where we basically break up each individual graph that makes up our finished result. So without further ado, I'll get into the first episode. So after watching the intro that I just recorded, I saw that half of my toolbar here was actually cut off. That was my fault. I set the screen resolution capture for the software I'm using to 1660 by 1050 or something like that. So that was on me. Now that I've got that sorted out, you guys can see all of my data over here. So to start off, we want to just create a new substance, and our first graph is going to be called mud. We're going to leave it relative to parent because we want to be able to change the sizes of this material outside of Substance Designer. And to start off, I like to go 512 by 512. This just lets me know that even when the texture is small and not as high quality, if it looks good, it's going to look good when it's bigger. Inversely, if it looks bad, chances are it's probably going to look bad when it's bigger. So I like to start off a little bit smaller than what we would be using in, say, a game engine. So I hit OK. And now we've got our black cube, very reflective, and you can see it's pretty much 100% reflective with our HDRI. And what I like to do is right off the bat, save it. Because you never know what you're going to do next. Well, hopefully you know what you're going to do next, but I never know what I'm going to do next. And find a place to save this. So once you've found a spot to save it, you're going to want to save your file name as the name of your package. So you're not saving your graph, you're saving your package, which all your graphs go into. You can think of this as kind of like a folder or a container. So I'm going to name this trench mud, and you can see it saves it as a .sbs. That is a substance file. Substance Designer will recognize this natively. Alright, so now that we've got our mud graph and our trench mud material saved, we can go ahead and start. What I normally like to start with is utilizing a base material to just display our outputs. I don't like to use these guys because we have to plug in and plug out and, you know, move nodes around all the time if we do that. And if that's what you want to do, that's fine. I like to use a base material just so that we get a pretty steady workflow, pretty consistent. We don't have to play around too much with the outputs when we're just trying to test geometry. So just hit space, space bar, start to type in base material. And there we are. So we get this little node here. So I put this right up against my outputs. And as you can see, we've actually got some instance parameters that we can work with already. So off the bat, I change this to dielectric. And I want to be able to plug in both my normal map and my height map into this node. And as you can see, it's now given me two inputs to use. So I can right click this and just view in 3D. So now it's going to demonstrate or basically display this node in our 3D view. And you can see it's a dielectric, it's relatively rough, and it's gray. That's perfect. That's exactly what we want. We don't want anything too complex right now because that's what we're going to work towards building. So from here, I just like to take my normal map, just a basic normal map, and plug it in. And as you can see, it gets a yellow ring or a yellow border around trouble nodes, which are going to basically cause us issue when we're importing into Unity. How I got about creating this safeguard is if I go up to my file, actually, sorry, it's in edit, and preferences, we want to go to projects and compatibility mode. So what this does is it shows us nodes that are compatible with, say, version 6, version 5, or version 4. Meaning, it's going to show us, if I select 5, hit apply, any nodes that are introduced to Substance Designer after version 5 is going to show up with a yellow border. Meaning, hey, this node wasn't in Substance Designer 5, so it might not be compatible with some things. And in our case, that compatibility issue is going to be with Unity. Now, a nice thing is the fill alpha with input version of the normal was in Substance Designer 5. So we can just use this alpha content channel, and we've totally worked around getting our normal maps into Unity 5. Wonderful. So we've already worked around our first issue that we were going to get when importing into Unity 5. So now I've got my normal input and I've got my base material, and we want to start working with our geometry, because the workflow that I like to work with and is pretty common is going from our grayscale black and white images, which dictates our geometry and our height, our normals, and we work towards more color-oriented data such as albedo maps and even our normal maps to a certain extent. Our normal node, this will be the last node before we plug it into our normal output. However, we also use it just to illustrate a height data and lighting data earlier on. First thing with normal maps I like to do is I like to set the intensity up to 7, just so that we can really see the normal data that we are inputting, because oftentimes if you can't see the micro surface detail that you really want to see, it's because your normal map is just too low. The intensity is just way too low, and it's not outputting any meaningful data for you. So I just like to turn that up to 7. So let us start. What I start with normally on most organic grounds textures or materials that I make, I like to start off using a clouds 2, because it gives you a lot of fatter high area surfaces, but it also gives you those, you know, more recessed areas which are darker on your map. And I like to blend this with a black and white spots, and I just use one. I like the way that it looks. It's pretty noisy, pretty messy, and I like to just blend these two guys together. However, I don't actually use a blend node. I use a slope grayscale blur, because I don't actually want to use this data over top of this data. I want our black and white spots to actually distort our clouds texture. So as you can see, when I plug this into slope and we choose the output, it's really messed it up and that's not what we want quite yet. So we want to bring the samples up and we want to bring our intensity down. And now you can see it's almost like crystallized this, like we're looking at it through a like foggy glass. So we can just continue to bring the intensity down, because I don't want it quite like that. And now you can start to see how we get that cascading effect, right? It's really posturized and blocked out our color values. So now you can see distinct levels in our geometry. So I play around with that a little bit. Sometimes I like to change our mode. It really depends on, you know, circumstance to circumstance. And here it doesn't really seem to be making too much of a difference, so I'm going to leave it at blur. Now, I don't like how we've got this little black recessed area in the corner. And I want to be able to maybe move that towards the center of our texture without having to, you know, rely on too many other nodes where it's warping and blending and blurring. And we actually have a node that can just move a texture in the 2D space and keeping it entirely seamless. And that is called the transform 2D, or the transformation 2D node. So I'm going to plug it into our clouds, and I'm going to double click just on our slope blur so that we can see the results of this guy. I'm going to single click, and I'm just going to go into our 2D view, and I'm just going to click and drag until we kind of get where I like it. And I want to do something more like that so that our black, our recessed areas are more inside the texture versus being on the corner where we might run into some tiling issues. If we bring this into another engine, it might not be able to quite read it as accurately as a more neutral color. And so we might run into some issue where we're having recessed areas not lining up perfectly. From there, I'm going to just single click on our graph, and I'm just going to hit Control S. And as you can see, we had an asterisk up here. Now it's gone. Just to make sure to constantly be saving your graphs and your profiles, because we don't want to lose any of our hard work that we've spent copious amounts of time working on. So now we want to actually start seeing something in 3D. Well, we've got this guy right here. And for all intents and purposes right now, this is our height map, because it's the only geometry data that we have. So what we can do with a normal map is actually plug in our height map into the normals. And we can also plug it in to our height map input that we decided we wanted on our base material. And now with this, we just right click on our material and hit View in 3D. And now you can see we've actually got our 2D image mapped out onto our 3D object. And you can start to see the cascading effects. Again, it's also 512 by 512, so keep that in mind when looking at the texture quality. We can change this parent size at any time, as we indicated when we created the graph. And if you accidentally hit absolute versus relative to parent size, don't worry too much. If you double click on your graph, we can also change that up on our base parameters and output size. If you had set it to relative to parent, you can see here, as we have, it will be relative to parent. But we can also change this to absolute, and now we can't click on these because we have to indicate what size it's going to be up in our output size base parameters. We don't want that though. It's not versatile. It isn't evergreen. We want to keep it so that we can change it on the fly whenever we want. And as you can see, quality is really improved. But for now, I just want to keep it a little bit lower because I don't want to work with too much detail right now when I'm just trying to do the block out phase. So now we've got our base geometry for the mud, as you can see in our 3D output. And now I want to create our air pockets or air bubbles for the mud. The way I go about doing that is I add a shape node. And as you can see right now, it's just giving us a square. And I want to use a Gaussian. As you can see, it gives us this small little pebble looking circle. And we're going to use this as basically the main geometry for what our little tiny air pockets are going to be. I also add in a polygon 2 node, and we're going to use this to basically subtract from our Gaussian and give it more of a rounded but somewhat jagged edge to it. So I'll double click on our polygon 2, and I want to start by just giving it about 5 sides. The scale is okay for now. And we're going to just turn the gradient down. And as you can see, once we start to move or peel away the gradient, it just goes to pure white. It goes from black, gradient, and then pure white. So it's just eliminating a bit of the distance that it takes to get from black to white. So we'll leave it about halfway. Halfway is okay for now. And everything else looks good so far. So I'm going to click on my polygon, and I'm going to add a splatter circular node. And what this does is it takes the input of our polygon 2 and it puts it around and it just splatters it in a circle. It's basically what the name of the node is, splatter circular. Now we have to change the pattern because it always by default selects square, but we want to actually use our image input. Now you can see it's taking our pentagon and throwing it around, splattering it around in a circle. So I'm going to bump up just the number that we have. And I'm going to also increase the radius a little bit. I'm going to leave the radius random to 0 for right now. We might come back and touch that later. And I want to just increase the pattern. So you can kind of see now we're making a circle. And the idea of this is that we're going to make it around this guy right here and have the white come in at different points, and we're going to blend these together and have it subtract. So the white points are going to take away from any of the white surface of our Gaussian. So it's going to start becoming jagged, kind of like this, but we're going to also have that rounded top that we want, that air pockets are going to have. So we've got this guy right now, and we want to change our blending mode. As you can see right now, it's kind of just really ramping up the white as it blends together. I don't really want that. So we're going to change the blending mode to max, so that way we actually get some distinction between our inputs or our polygons. This is just going to give us some more randomness when we're subtracting it from our shape. I want to take our luminance by scale down as well. Actually, I'll demonstrate what this does first. If we change the pattern scale, you would see the smaller ones start to decrease in their luminance or their value. They start to become gray, almost towards black, once we ramp it all the way. I don't want that, so I'm going to go down and change our luminance by scale to 0. So now even as they get smaller, they still remain white. I'm going to bump this down again. And I've decided these are too small, so I want to bump these right back up, and let's hit 5. And there we go. We've got something that looks like it can start to eat away at our Gaussian blur. So now I want to start viewing this and seeing how it's affecting our Gaussian. And so I'm going to add a blend node to it, and we're going to input our splatter into the foreground. So now we need to change our blending mode down to subtract. And you can see now the actual surface detail is almost like it's jagged edges with a round top. And that's how Substance Designer is going to read it. It's going to read the very, very contrasting sides as sharp, jagged points, but the middle volume data is going to have a very rounded top, as a mud bubble would have. However, I do not like these jagged edges quite yet, and so we're going to go back and we're going to keep working on this. So now you can see I'm working with the pattern scale size and the randomness, and I want to be able to see my blend node and see how the splatter is affecting it. So I'll double click on my blend and single click on my splatter effect. I want to bring my pattern scale up, bring the size random down, and now let's work on rotation, because right now everything is rotated pretty uniformly. So we bring this up, and now you can see how it's really affecting our data. So I did see one that I like. If I go back to the start here, and I like something kind of like that. So you can see that we've got these jaggedness, but we've also got some rounded edges. The top is very rounded, and it's going to give us a somewhat bubble-like effect to it. So now I don't like how you can kind of see, hopefully, our brightest point is a little bit off kilt of where our center is. So just like I did down here with our transformation 2D, I'm going to bring another one in for our Gaussian transformation 2D. And now you can see we get the anchors or the handles to move around and rotate. Can't really see a rotate there, but move it around, scale it up and down, and just overall transform it. I want to be able to see the output though, so I'm going to double click on our blend again and then single click on our transformation. And now this is where I'm going to move around, and you can see how the subtraction is working. So this is the result that we get total. And the only visible point is our actual Gaussian itself. This is what we use to basically find the geometry that we want to utilize. And there we go. It's in the middle, and that's what I like. That's the look that I was going for. And now we are able to finish up on our mud bubbles. Lastly, we need to make it tile. We've created one mud bubble, but if we blended this together now with our geometry, we'd get one smack dab right in the center of our texture, and that would be it. And let's just demonstrate this. So if I blend these two together, and I use screen to get rid of the black, you can see now, compared to our texture, it's about the same height that the rest of the texture is at. And you can see here, this is the actual end result of utilizing a screen blend mode over our base geometry. And that's not really what we want at all, because now it just looks like there's a flat little spot right in the middle of our texture. So to get rid of that blend, hit backspace, and we want to tile it. There's a couple ways we can do this, but the most effective that I've found is using a tile sampler. And by default, it's going to plug it into the background input. We do not want it there. We want to put it into our pattern input. And much like the splatter circular, it's going to choose a square as the default pattern. We want to once again find pattern and go down to pattern input. And now you can see our really tiny bubbles. And we've lost a lot of detail because of their size. We also don't want a uniform, you know, what is it, 16 by 16. That's going to look weird. So we can play around with some of these inputs and change the randomness and the tiling of our bubbles to make it seem more organic, more natural. So we're done with our pattern. We don't need that anymore. And I'm going to bump up our X amount and our Y amount, which basically just means how many are there going to be tiling across the X. X being our horizontal, and how many are going to be tiling across the Y. Y being our vertical. So if I set this down to 1, there's only going to be one row across, as you can see, and our Y amount is 9, so there's going to be 9 going down. I try and make these as close to similar as I can, because otherwise you get some funky looking stretching of your geometry that you just tried to create. So I try and keep them as similar as possible. Now sometimes it does look okay if you are 1 or 2 off. As you can see, there's no real distinguishable difference. But once we get to 7, you can kind of see now it's stretching horizontally. So I'm going to bump this up actually to 20 just to give us a starting point. And so now I want to change the scale of these bumps. So now they're a little bit bigger, as you can see, and we're getting more detail. can change the randomness of these sizes. And now they're not all the same size. Again, looking more natural because all the air bubbles would not be the same size in the real world. It still looks a little too procedural for my liking though. So again, we'll continue going down our parameters and just changing as we seem fit. So now we can change the position, and this is where it gets interesting. We can change the offset. Again, mess around with our position. And now our rotation. Now this will turn every object that we have uniformly. So as you can see, they all turn together. But once we get our rotation random going, now there's a lot that are turning on their own accord, independent of other air bubbles. As well, we want to make sure that our blending mode is on max. By default, I believe it's on add sub, and you can see that textures that are blending together become pretty much pure white, and we don't want that. So if you hit it by max, you'll be able again to distinguish where air pockets are going to be connecting with each other, and that just gives it a more natural look. As well, we can also change the color data of each pocket. And what this is useful for is once we get into actually blending it with our main geometry, these pockets are pretty white right now, and the height map is going to read that as really sticking out of the geometry. And actually, I believe we are pretty much done, so I can demonstrate that right now. So adding these together through a blend, just drag this guy up. I'm going to move all of our outputs over to the side so that we're not colliding with them. And now I'm going to drag this guy in. And you can see, while the air pockets look good on our 2D texture, they really like to stick out. And the smaller they are, the sharper they are. And that doesn't look too good. So with this color input, we can actually just bring this down. We want to bring it darker so that the bump isn't as contrasting. And now you can see, now they're kind of looking like bubbles. And we can play around also with color random, which will randomly color certain bubbles over other ones. Now again, this is bringing everything up, so we want to just bring our main color down. Maybe bring our color random back down as well. Have a little bit of randomness, but nothing too crazy. And I'd say about 19 or 20 is okay for that. And now we've got a lot of bubbles. Now I want to see how that looks with our main geometry. So I'm going to go down to our blend, and I'm going to go down to screen. What screen does is essentially get rid of any black values, pure black values on our texture, and overlay any white values on our background texture or our body texture. And as you can see, now we're getting slight bubbles all over the place. And if we look on our texture, they're not really visible. So I want to go back into our tiler and just kind of bump it up a little bit. If I do it to an extreme, you can start to see the bubbles very readily. But I want to do something that fits. So I'm going to bring this back down because these are used more as accents, not main textures. And now you can see it looks more organic. It isn't a focal point of what our mesh or our material is going to be, but it just helps to sell the illusion that, hey, this is actual mud. This isn't just a 3D render of a mud. We've actually got real mud in our computers. Again, just making sure to click on your graph somewhere. You can hit Control S and just save your graph, because now we've got a lot of data that we spent almost 35 minutes doing, and we don't want to have to do that again. So now we are ready to move on to our actual color data. So I'm going to get rid of this guy because we no longer need our base material. And I'm going to take our normal map and just plug it right into our normal output. And as you can see, we've got a nice, beautiful normal map. I'm also going to take our grayscale blend that we've done and plug this into our base color. And while we're not going to use this as our base color, we're going to utilize the grayscale values and put it through a gradient map to then dictate where we want certain colors. And it's perfect when you have materials such as mud where lower values are normally going to be darker in color versus higher values which are going to be lighter in color, because that's exactly what a gradient map will do for us. Our darker values will be a certain color that we can decide, and then as we get to higher values we can dictate which color we want those to be. So if I just click on this connection, I'm going to start typing in gradient map, and that's the first result, and I'm going to plug that guy over here. So I'm going to double click on that, and it's just going to show the input of our grayscale node. But now we've got this gradient editor if we go down into our parameters. And as you can see, we can either just click on here and start moving around, and you can see how that's changing our gradient map. But I don't want that. And in fact, I like to start off by using our pick gradient tool down here. And to demonstrate what it does, I've actually got a picture that I'm going to use is this guy right here. And so if I just minimize the screen a little bit, there we go, you can see how when I pick gradient it gives me this little tool, and from this I can actually click and drag and it gives me a selection based off of my gradient. So I'll bring this guy back. And you can see now I've actually got something to work from. I've got a start. And I never use the gradient tool as the last resort, but I do use it as a jumping off point, a starting tool. And now as you can see, we're still viewing our base material in the output. So if we go and right click on our graph and view outputs in 3D, now you can see we're utilizing our base outputs. And the first thing you might notice, other than the color, is that it's very, very shiny, more shiny than we had initially. And that's because our roughness right now is interpreting this as pure black. There's nothing. So it's just going to be super shiny. I just want to add a colored input right now, change it to grayscale, and just bump it up, because we don't want to have to look through the specularity. We just want to be able to see the color for right now. Okay, so now going back up to our gradient map and going into our gradient editor, we can start to drag around these values, and you can see that it's only changing specific parts. And this area in here is going to be our midtones. If you've ever used a levels node or a levels feature in Photoshop or any software really that lets you edit photos, you're going to have the midground as being your mid texture or your mid gradient, and each opposing end going to be your darker values and your lighter values. So if I mess around with this one, you can see that areas where it's in the middle height wise of our height map, it's going to affect. And now we can just mess around with the values. We can take out values we don't like, move values up. Normally what I like to do is bring my bottom value down to a little bit darker. Again, not black, but a little bit darker. And I bring my top value up, and let's make that more of a grayish. And right now we've got a lot of textures close together. I just want to get rid of those. I don't like to have the colors way too close to each other. It just makes everything cluttered. And now we can start to bring this down as a whole. And you know what? I don't really like this texture or this color. So I'm going to delete that guy. And it's not really looking like mud now, is it? It's looking kind of like clay. And that's not what we want. And it's because we're getting random uniform colors that aren't conducive to our workflow. And here's where you are able to decide what you do and don't want. So I'm going to play around with my gradient editor for a little bit and just come up with a result I like. And I encourage you to do the same. And I will see you after I'm done. Okay, so here's the result of my gradient. And as you can see, I've started with a dark texture or dark material just for the inner recesses. And as I work my way towards the top, just getting brighter and brighter until the very top layer where I've actually made it darker again, just so that this is the layer where it is most visible and most exposed to the outdoor environment. So it's going to be a little bit weathered and a little bit worn, and it just adds a little bit more variety to our overall material. So from there, I want to go about adding a little bit more variety in our albedo map. And what I mean by that is I want to start adding some more random grains of dirt and some more variety where it's not just levels of our material, but actual other materials on top. And so how I go about doing that is if I drag this guy back, I'm going to add another gradient map. And from this gradient map, I'm going to drag and drop our black and white spots node that we used at the beginning. It's a good idea to always use nodes that you already have in your graph as opposed to bringing in more nodes if you can help it, because then that is less nodes that your graph has to load when loading your material. So it's always good practice to just reuse and recycle nodes. So as you can see, we've got a more grayscale gradient map because that is our only output. When we come back over to our gradient editor, we can once again change our values. So I'm going to use pick gradient, and I'm just going to click and drag on top of our already created albedo map. And this just gives me a jumping off point for, again, my new variety in dirt. So I'm going to blend the two together because I want to see what it looks like when it's on top of my albedo. And you can see here, this is purely just what our dirt is going to look like. So if we just leave our blending mode on copy and we actually take our grayscale image of our black and white spots that we've also used as our input for our gradient map and just plug it in to the opacity of our blend node between the two, we can effectively use this as a mask and basically block out where we want to use this texture and where we want to use this texture. And you can see on our 3D and in our 2D, we've got our overall color data with subtle hints of gray, grunge, and surface imperfections. And we can kind of see it on here too, where we're just getting a little bit of dust and dirt debris over top of our color data for our main geometry. And that's the look that we want. We just want to have a little bit more variation when it comes to our color data, because they can go a long way in selling the illusion that this is a real material. So now that we're working with more color-oriented nodes, we can actually go and just change the parent size up to 1024 or 2048, whatever you really want. Again, I like to keep it small as to make my render time a lot quicker, and I like to just make sure that if it looks good when it's lower quality, it's going to look great when it's higher quality. And now that we've got some color data already in and how we like it, we can start working on how it actually reflects light. So I'm going to remove this uniform color, and as you can see, now it's going to be just a really shiny mess. And what I like to do is go back to our black and white spots, because it's the right amount of randomness that we've already utilized in our material, and we already have this node in our graph. So I'm going to click and drag and drop it right into our roughness output. And as you can see, it already looks 10 times better because there's varying wet spots versus rough spots versus in-between spots, but we can actually make this a little bit better. And so what I like to do is I will just add a levels node. And I will bring this guy over, and now we can actually affect how bright our shininess is going to be and how rough our roughness is going to be. As a rule of thumb, I never have anything as pure black or pure white, because in the 3D realm, pure black means pure reflection, absolute reflection, and pure white means absolute roughness. That's not how the real world works. Nothing is ever pure white or rough, and nothing is ever pure black or reflective. There's always some minor variations and some limitations to that, so I like to just reflect that in our materials. So I'm going to drag our bottom arrows on our levels node, which is our outputs, meaning it's negating any of these dark values and basically bumping up our darkest value so that it's no longer black. As you can see here, black, and it's very shiny, and as I bump it up, becomes gray and not as shiny, not as reflective. Now I don't want that much. I do want a little bit darker values because mud can be wet, and as we know, wet mud is pretty shiny. And the same thing goes with our white values. Nothing is ever absolutely rough. Nothing is so rough that it reflects no light. Everything reflects light, even if you can't visually perceive it. So we can bring this down, and it's bringing our roughness value, our white, down to a gray. This allows us to start seeing more and more reflections take place. And if I really crank this down, now it's going to just be wet because it's such a gray, dark color map, or in this case grayscale map, that it's going to just basically be like the wet mess that we had initially. And if that's the look you're going for, then all the power to you. But this is not what we want for this case. So we want to bring this back up so that there is some color variation, or grayscale variation, I should say. And for now, I kind of like this. You can see that it is shiny, but there's also parts where it's not so shiny, and it just helps break up the monotony of having either completely reflective or completely rough. From there, we go down to our metallic map. And what a metallic map is essentially a black or white uniform color indicating whether this material that we're using is metal or non-metal, and non-metal we refer to as dielectrics. If I bring in a color node here and I just plug this in, right now we're indicating to our output that this is black, meaning 0, which is non-metallic, a dielectric. If I were to crank this up, putting it in grayscale mode, if I was to crank this up to white, you can see now it kind of looks more like it's a bronze. This is indicating that we want this material to be viewed as a metal, which is not the case. As we know, mud is not metal. So we want to bring this guy down to 0, meaning black. The thing with metallic maps is it has to be either 0 or 1, black or white, because there's no in between. Nothing is ever somewhat metallic, but not really metallic. In the real world, this would not make sense. It's partially metal, but it's also partially not metal. It doesn't exist, at least for the intents and purposes of this tutorial. Semi-metals do not exist, either white or black. In this case, we want black. However, we're not done, because we don't want this to have to load a 1K texture, 2K texture, 8K texture, whatever we decide our parent size to be. We don't want this to have to load a purely blank or one color node every time. It's just a waste of resources. So what we can do, so if I drag this guy back, we can go out to our output size, making sure that we double click on it, and we hit absolute. And now you can see this is going to give us the absolute size that we can dictate what we want this to be. The best bang for our buck is leaving it down to 16 pixels by 16 pixels. However, now that we've got this as 16 by 16, our output is going to be 16 by 16 as well. And we don't want that because in Unity, we actually use the alpha map for the metallic output as the smoothness for our object, or basically where the roughness is going to be or the glossiness is going to be on our object or material. So I'm going to input a levels node and just drag and drop that guy up here, and I'm going to double click on him. And on output size, I'm going to put this relative to parent, and the difference is this is now going to have an output size relative to what we set the output size to be of our entire material. Whereas relative to input is going to take on the output size of whatever is plugging into it. In this case, our uniform color, which is 16 by 16, and we don't want. So now we are good to go with our metallic output. So I'm going to just shove those guys off to the side, hit save, and we are good to continue on. And for our height, well, we've actually made our height map already, and we don't have to do too much in terms of fiddling with it or messing around. So I'm just going to drag and drop our blend between our mud bubbles and our geometry, and just drag and drop that guy into our height. And as you can see, now we get our height information back. And now it's looking good. However, we do have one more node that I want to cover because it is very important to making your material just look that more realistic, selling the illusion that much more. And as you can see right now, you probably can pick it up with your eye, but you can't quite notice what is wrong with it. And we don't have a lot of shadow detail. We need ambient occlusion to basically rough in where we're going to see the shadow detail along proximity objects, things that are close to each other, along the bottoms of edges where we're going to get more occluded light. So by default, we don't actually have an ambient occlusion output. So what we have to do is hit spacebar and start to type output. And so we'll get this guy right here. We want to indicate that we're using it for an ambient occlusion. And I'm going to just copy this because we're also going to put this as the identifier. And as you can see, now we've got ambient occlusion up here. And I'm just going to change the label to ambient occlusion as well. And now we've actually changed the more visible name to ambient occlusion. Lastly, I want to make sure that in the group category, we label this as material. And you can see that with our other outputs, they are all in the material group. And this will make more sense once we get into actually blending different graphs together. But for now, just leave it as material and then we'll be good to go. So now that we've got our output all situated, you can just hit spacebar and start to type in ambient occlusion. And it will give us this ambient occlusion horizon-based filter. So if we click on that, you can see that we run into another compatibility error. And this time, it isn't any parameter that we can change within our instance parameters because the horizon-based ambient occlusion node is exclusive to Substance Designer 6. So the node itself is the error. I will leave it in just to demonstrate how we're going to go about circumventing this for use in Unity 5. As well, if you don't plan on utilizing Unity 5 for your end result, you can just skip this next part, plug in your height, and you'll be good to go. Again, make sure to just fiddle around with some of your parameters, but the base is pretty good in and of itself. So for use in Unity 5, we want to try and achieve something very similar to this. The method I've established is by using curvature nodes. So if we type in curvature, you can see that we actually get 3 different nodes. The 2 that we want to use is curvature smooth and curvature sobel. So I'm going to take our curvature smooth, and you can see here that its input is actually a normal map, and we haven't used the normal map for an input in any of our nodes. So I'm going to take my normal map and I'm going to plug it in, and you can see here what it's done. So if I just force the alpha to 1 on this here with our normal map, that we can start to visualize where our edges are, and we can see that it's actually demonstrating to us or displaying to us values which indicate which direction light should be bouncing. Our curvature takes that data and essentially puts it into a grayscale form. So we're getting the same data, however, more grayscaled. The second map we want to add is our curvature sobel. We don't want to add it to that guy. We'll bring this underneath. And it starts to give us very similar data. However, it emphasizes more of the edges and the crevices of our normal map. So from these 2 maps, we are able to circumvent and work around creating ourselves a horizon-based ambient occlusion map. So I just move these guys off to the side, and I'm going to start by looking at our sobel. Again, this one is very harsh on our edges, and I just want to blur the edges so that we aren't getting such harsh contrast. Again, just bring the intensity down. Anywhere from 0.2 to 0.3 is good. We don't want it to be too bad, just enough so that it isn't black and white. And from our curvature smooth, we just want to add a blend node, because now we're going to blend these 2 together. And again, we need to change the blending mode because right now it's only demonstrating our curvature sobel. And for this, we want to use overlay, because now we get both the edge data from our curvature sobel and we get our face volume data from our curvature smooth all together in one package. And now you can see it's getting pretty close to what we get from a horizon-based ambient occlusion, but we're not quite there. As you can see, we still need to mess around with the levels in order to create our white. You can clearly see that this has got a lot brighter values as opposed to our more gray map. So we need to use a levels node. As we crank down the white handle, you can see that our map is getting a lot brighter, which is fairly close in color with our ambient occlusion. However, the darker areas are also pretty dark in ambient occlusion, where we're kind of washing them out in our curvature maps. So I want to just crank up the darkness a little bit and just play around with your points to try and get something that is very similar to our ambient occlusion. So now I've got something that I'm happy with. It's very close to our ambient occlusion filter, and I think it will be okay when using it in Engine. So I've got a result that I'm pretty happy with, and we'll be good to go. We will plug this guy in, and now we can start to see our shadows a little bit stronger in the cascades of our mud. It just provides a little bit more detail in our geometry that our height map couldn't quite get. And now that I'm looking at our material, I don't like how low these recesses are in the mud. And so I'm going to go back down to our heights, and I'm just going to add another levels node. And I'm just going to take our black output and bump it up ever so slightly. And as you can see now, our recesses aren't so black on our map, and they aren't so deep into our texture. So now we can get rid of our ambient occlusion. We don't need that anymore. And we can start to do a bit of cleanup on our graph. I hope that video was useful for you guys when creating our first base material. It was pretty complex in some parts, so if you didn't keep along, that's okay. Hopefully you're still motivated enough to continue in the series, with our next episode focusing on our rocks. Stay tuned, and I'll see you guys in the next episode.